So, Nick, let's talk a little bit about rendering in the cloud. We've
Sure.
rendered on-prem for a long time. Everybody's really familiar with how that works. Um, why would you set up a render farm in the cloud? Why would you go to AWS or Azure, GCP? What would make you want to move everything that you've known and done for 10, 15, 20 years? Why would you change that, right? You know, when you put stuff on-prem, you know what you're getting, you know what you're paying. What would make you want to go to the cloud for that workflow?
Sure, Jason. Well, the reason you would want to move a render farm workload or any workload to AWS or any cloud service is it allows you to achieve what we call the 5 pillars of excellence. And those 5 pillars are operational excellence, operational excellence, security, reliability, performance efficiency, and cost optimization. We can go into those uh, into detail, but essentially it lets you execute your render farm perfectly. It lets you execute your render farm securely. It lets you execute your render farm reliably. It lets you execute your render farm efficiently, and it allows you to execute your farm cost effectively.
Okay, so let's talk a little bit about cost really quick, because I think that's going to be what's at the forefront of everyone's mind in this.
Sure.
We all know that we can put pretty much any workload we want into the cloud, but how do we put rails around what it's going to cost at the end of the day? That's always the big stumbling block that we have when discussing render farms that are in the cloud with customers is we can get everything up there, we can spin up the machines, we can move the assets. And I mean, this is all, depending on the size of the project, may be easier, it may be a Herculean task. But at the end of the day, how do you know what it's going to cost you? How do you know that it's not going to be cheaper to do something on-prem than it is in the cloud? Are there controls we can put into place, or are there ways we can manage that up front so it's predictable?
Yes, of course. There's several points on the cost optimization pillar, and we can discuss them now. The render farm in the cloud it turns the cost into a consumption-based model. So you're paying as you go. There's ways to optimize even that, and so you are able to achieve a different cost structure than buying your on-prem gear. And there's benefits to the on-prem gear, but we can address those, as they come. In terms of the cost, it's a change from that capital expenditure to the operational expenditure. So that consumption model is helps you be more helps you optimize. And you'd mentioned measurement. The cloud is very, very rich in measurement. There's thousands and thousands of data points that we can graph and metric, and a lot of them work by default and are on by default. There's several to set up, and there's ways that you can measure your farm, your usage, and calculate and have your auto scaling tie into that, such that you're using and paying for what you use. So you're using what you need and paying for what you use.
So would those management tools be something that are integrated into the queue management software that you're using, or is that something that is native to the cloud platform that you're using?
It's
or,
a little
or both?
Yeah, it's a little bit of both. It's a little bit of both. The render farm management tools can utilize those because the cloud is API driven and all those metrics are available over the rich API. But then also inside the cloud, when you're setting up the infrastructure, or if your render farm is setting up the infrastructure, it's both models. You tune and have the cloud infrastructure auto tune based on those metrics as well. So you're not spinning up excess machines, you're spinning down machines when they've been idle for more than X amount of minutes, um, those sorts of things. So you're measuring how efficient you're being with your farm, your compute load, and you're putting the right resources in place to match the demand of that render job.
So you need to be vigilant about what the costs might be, but there's a lot of tools in place that can help you put some structure around those costs as well, is what you're saying.
Yes, exactly. It's a pay-as-you-go model, and so there's the other side of that. But generally, you can, with a little bit of measurement, you can keep an eye on that and keep the costs under control. So.
Okay. When we first started talking, you were mentioning the 5 pillars, and one of those was executing the farm with excellence, right? So how long does it take to get a render farm set up in the cloud, and how do you execute it with excellence in the cloud in a way that you may not be able to on-prem?
The measurement of the timescales for the cloud would be in the hours, not in the days. So putting any workload in the cloud is something that can be done in a very short amount of time. We can it can be proof of concepted and executed given an AWS account. You create the resources that you need to execute the test. You tear them down when you're done, and you recreate them again. That starts off your process that you should adopt when implementing the cloud, which contributes to that operational excellence, which is the continuous integration and continuous deployment. Essentially, everything is code, operations is code, all cloud infrastructure is code, all render farm config is code. And so when you're putting up, go ahead.
Sorry, go ahead.
When you're putting up the infrastructure, you're measuring it. You're measuring the cost, the billing by the minute, and you're improving it as you put up your service the first time. You don't have the right firewall rule in place. You can't access the service. Services can't talk. You're going to iterate that. You're going to commit all that to your version control, and you're going to deploy it. And so you're going to track that over time for your initial proof of concept. And then once it moves into a production environment, you're going to follow the same practices, which improves the operational excellence over time.
So when you start talking about things like infrastructure as code, that might sound foreign or possibly intimidating to some people who aren't used to thinking of their pipelines in those terms. Is that something that's an easy transition for people to make, in your opinion?
Yeah, it can be. It's a little bit cultural. It's a little bit technical. So there might be an introductory point. A lot of studios with their pipeline have custom code already, and so we might be able to introduce it to them from the side of the pipeline, showing how it's really just an extension of software, and that's really what the cloud is. It's all software defined. So if you think of it that way, maybe it's a little bit less daunting.
Sure. Okay, so when moving render farms to the clouds or extending them into the cloud, what render farm management software would you use to do that? And I think there's one elephant in the room, but are there others?
Yeah, Deadline it's great. It integrates with AWS. It's very turnkey. If you need to extend it to a more custom solution with some custom code, custom applications, or custom pipeline, then you do need to start dealing with the infrastructure directly. But Deadline can be aware of that, but you have to provide Deadline with that CloudFormation template and put it in the right place in Deadline. At that point, it really almost becomes just an extension of Deadline. It's a bunch of AWS CloudFormation code inside of that farm manager, and then it will take care of provisioning the infrastructure on demand. Similarly, with other render farms or perhaps a custom solution at a studio that has a custom render farm manager, the AWS can be implemented in a similar way. We can provide a base infrastructure in the cloud that connects to their on-prem using a similar VPN technology that we know, and we put a file caching in place that's needed to allow data to be moved efficiently back and forth between the cloud and the on-prem. And then they wire up their render farm manager software using nodes that they sort of treat like an on-premise node, but it's going to render on the cloud. And so, as for the preferred, we'll work with any, but Deadline is number one, and some other vendors might have some integrations as well.
And I would think, correct me if I'm wrong, but I believe Deadline does now have some asset gateways that work in conjunction with AWS to make sure all the assets are where they need to be. Correct.
That's correct. Yeah, the asset portal server at the gateway, it's a service, and it has a couple parts that operate over a couple of different ports and such that let you do exactly that using S3 as a backing, very cost-effective storage, blob object storage in the cloud, and move the assets then to a temporary file system with that the nodes can access in the cloud. They render, and then it moves the data back and forth out that direction.
So with those many assets moving back and forth and that much data coming back from the cloud, are there some sort of baseline connectivity requirements that you've seen, or is it dependent upon the amount of data that's being pushed to the cloud?
There is definitely a baseline. 100 megabit is a good baseline for any type of real-time type of rendering to allow the data to move. That even isn't enough with a lot of users on a lot of nodes. Gigabit connections definitely would perform better. If the data requirement is too large, there's solutions. AWS calls it direct connect. It's essentially an MPLS line or a direct connection to the data center using some ISP and provider services that allow us to get low latency and high bandwidth into the AWS. That takes some weeks to implement and varies by availability, but ultimately that's where you would need to go to do a hybrid cloud that's relatively transparent, and uses a lot of traffic, sends a lot of frames back and forth.
So we're talking about moving a lot of compute to the cloud. We're talking moving a lot of data to and from the cloud. How do you properly implement security across this kind of environment? Because we're talking about highly sensitive intellectual property. What's the best way to leverage this cloud rendering power, but still make sure that these frames don't fall into the wrong hands?
Absolutely, yeah. Security is a core principle in the clouds, especially AWS. There's a few different ways to implement strong security. AWS follows these best practices from their side of the responsibility, and then we also follow it on our side of the responsibility. And that responsibility is the shared responsibility model. There's high security all up into a certain layer, and then the customer takes over. We inherit all the intrinsic security below, and then we implement all the security moving forward. Some of the things that we get by default, we have private networks. So all of our traffic and communication between nodes and to and from the services that we've described is not exposed to other customers. So only we can see our own traffic. Another benefit and that another foundation that we benefit from is AWS's strong identity foundation. That means that all interactions with the cloud are by user. So any type of interaction is going to be tracked, and that does extend all the way to the application level or the network level, capturing data and tracing data that way. AWS provides traceability across all of the customer responsibility controls. So from layer 3 up, essentially, you can track and metric. They recommend that you apply security to all those layers. So all of the things that we know, all the type of identity management still applies. AWS provides services to make that easier. They also recommend still encrypting data. They provide tools for encrypting data at rest and encrypting data in transit. They always provide and recommend using SSL when possible. Tunneling through VPN is highly recommended for any type of interaction over the public internet. We can even set up the infrastructure to, for example, the deadline by default will communicate with the public API. So there's sort of a public data vector, but it's it's encrypted through transport security. But you can route that through your infrastructure and have it talk to AWS via your VPN, your infrastructure VPN. So you can control your traffic that way and keep all the traffic private. So you're not even using the public internet in a very public way. You're using it through a VPN tunnel, not talking to AWS directly. You're going through the tunnel so you can keep everything.
So you're talking about using the public internet as a control channel almost, but sending all the data over secure channels. Is that what I'm hearing?
Somewhat, yeah. You can choose what services you want to use the non-control channel and only talk to the API through the public API to set up your infrastructure. That's definitely a model you can do. You can even talk to the API privately too. Once you set up that service through the VPN as a service, then you can talk to the API. Is through the service. So it's a very once you set it up, you can then you can move all your traffic to through the service endpoint. It's called so.
So all the security tools we need to be compliant are there. So, we set people up to be TPN compliant all the time. We can extend that into the cloud, is what you're telling me, correct?
Yes,
And
yes,
yeah,
yes, and at a very auditable and traceable level. There's
right.
a lot of tools provided to do checks for a lot. They actually have a built-in tool, audit tools for a lot of standard industry, so you can do quick checks and do security passes, schedule them so that way you can essentially have your security test as code and run those tests periodically, weekly, daily, whatever hourly it needs to be, and then get a report back, and then you can treat each of those violations, or if there's no violations, log it and move forward from there.
So in
Continuously
some ways,
improving the service.
the security might be better than what's on-prem already anyway, unless somebody
It's
has a very mature
you
and
know
advanced security practice, because you're leveraging the security that's in place for the rest of the cloud customers already.
I would argue that.
Yeah, yeah, makes sense. All right, so this is kind of open-ended question, but what will it cost? What does it cost to do this? I know it depends on what you're rendering and how much and how big the data is, but I guess a more accurate question might be, does it cost more or less than doing it on-prem?
Sure, absolutely. The quick answer is it'll cost less. The uh, the long answer is it's a operational expenditure. So it needs to be built to be efficient. It needs to be built to scale with the workload. You optimize better than you could with on-prem because you can scale down. That option doesn't exist with the on-prem, and so those times you can utilize that low cost. As to exactly what it will cost, there's a base cost and it's in the hundreds, and then what it will cost really depends on how quickly you want to render. AWS has the capacity to scale to the thousands of nodes across multiple availability zones, and you could drop a number of nodes in to tackle a very large job very quickly, but the cost will go up accordingly.
Well, I think what you
I'm not sure where to
said
go from there.
about no, that makes sense. I think what you said about tuning the operational, to basically tuning it for performance and tuning it to be optimized was where we help, right? That's the things that we can help people do. I think controlling the cost is one of the most important things we can do, along with security, helping people
Yeah,
optimize their pipelines and know where to put assets, know what to put into the cloud, know what to keep on-prem, and have those honest discussions about what makes sense to put where, you know, um, and how long it might take to do something and how much it might cost to do something in these various places.
sure.
So yeah, that's short answer is it's cheaper, right? If you do it the right way.
Yeah, if you don't blow out your bill, which some
Right.
people have done. I've
Yeah.
done it, not not for
Well, I
customers.
think that's part of the issue, right? Is maintaining discipline around using the cloud. So we see this a lot of times. Other customers, they'll developers kind of get used to having the ability to spin up machines, which they're very good at, but
Yeah,
they're not always so good at spinning them back down when they're done. Right?
no,
So
yeah, and that's
yeah.
kind of them treating them, they treating them as a cat versus cattle. They say like, treat servers like cat, you treat uh, cloud like cattle. You have a bunch of cattle, one cat kind of thing. So that I think we touched on that sort of at the beginning. You actually
Sure.
mentioned it about the
You name
cultural.
your cats, you don't name your cows.
There you go. Exactly. You brand them, right? So it's like that's kind of like same in the cloud. We tag all the assets. That's the idea. Is you don't want idle servers. I mean, that's the short of it. You don't want that. So maybe we
And
can
that's
come
where
up.
spot pricing comes in a lot of times, right?
Well, yeah. I mean, that spot is bidding on people that bought too much, right? And you're like, oh, I'll take that at a reduced cost. Everyone gets a reduced cost because it's already sort of sunk and subsidized. And yeah, the reserved is also strong. Reserved is also very, very cost effective. Um, but the spot is the best for sure. So, but that is just a billing. So if you implement the cloud to autoscale, then you slap the spot in and you're good. You know, it's just sort of that's the blend. It's when you don't go, when you just go into on demand and click, click, click and build it without building it as code, building it comprehensively, building it so you can fail over into another region or put your auto scaling in place quickly or whatever it is. That's when you get into the cost trouble because you're treating it like a cat. So.
Yeah. This has been a good talk, man. This is I love talking about stuff like this. So I'm looking forward to tackling more of these render in the cloud opportunities with you. It's gonna be a lot of fun.
Yeah, I'm really excited. I have a couple architectures done in the client folders. Nikita's seen it. One goes with a statement of work. One is, I'll look. One's just Falcon so I don't know if there's like an official project for that or whatever. But I talked with Mark and he was really excited about it. I mean, he's workstations, powerful workstations. They have storage gateways. They have cloud render. Some maybe local license servers. That to me seems a little, artists right there. It's very inexpensive to run that, and then they have all that heavy lifting compute. The just seems like a good model for a 12-person, 20-person studio.
Yeah.
Start to get to the other sizes. It's a little bit different, but even then you could have a cloud per department or a cloud per whatever.
Sure, there's lots of ways to tackle it. So I think this is a good place to kind of get people started understanding what's out there and how we might approach putting something in the cloud. So